नमस्कार दोस्तों। आज की वीडियो में जो है और देखेंगे कि हम प्रेजेंटेशन ऑफ रेनफॉल डेटा को जो है हम एक्सप्लोर करने जा रहे हैं। सबसे पहले हमें सबसे पहला क्वेश्चन होता है किसी भी टॉपिक के लिए कि हम प्रेजेंटेशन ऑफ रेनफॉल डेटा ये हम क्यों करने जा रहे हैं। लाइक अभी तक हमने क्या पढ़ा, लाइक वी आर स्टडिंग हाइड्रोलॉजी. So in hydrology, till now what we have covered, we have done the overview of water cycle. Okay, water cycle, and after that, what is precipitation and what are their forms, types, and the form rainfall, how we can measure it, what is the type, what is the need to measure. So all those things we have covered till now. So currently I am going to explain like the presentation of rainfall data. So how rainfall data is presented. Suppose there are like a non-recording type rain gauge. Okay, a recording type rain gauge. So many recording type rain gauge are there. Recording type, non-recording type of rain gauge are there. So how they collect the data, how they represent the data, and how that data will be good, or how that data is easy to use for the further analysis and other purposes. Okay. So in non-recording rain gauge, as I told you, at every day at 8:30 a.m., uh, the officer or the duty person they collect or they note the reading of that bucket which is installed there to measure rainfall, means rain from the rain gauge. Okay, so in this type of rain gauge, like non-recording type of rain gauge, that is a bucket where funnel is there. Okay, uh, so uh, the rain comes into this bucket, and the amount of rainfall we have to note in a logbook. Okay, so that logbook may be in the form of any thing when it start from 1st June. Suppose it start from 1st June. So first day at 8:30 a.m. They have to write here 1 mm rainfall. Okay, on 2nd June the rainfall will be 2 mm. So here they have to write 2 mm, and we have to write here cumulative as well. So here cumulative is here 1 mm, here 3 mm. Similarly, we have to write cumulative as well here. Okay. By this, at the end of the year or end of the season, you have to report this cumulative. Like in this year, this much of rainfall has been taken place takes place. Okay. So this method is used to measure, to represent, to present, or to log the rainfall in non-recording gauge. In recording gauge, there are some like weighing bucket type, tipping bucket type. So they have attached log book. Okay, they have attached log book. They create like master here time and time in hours or days, and here like first rainfall takes place. Okay, then second rainfall takes place, then third rainfall takes place. So till here this is first rainfall, till here to here this is second rainfall, till here to here this is third rainfall. Okay, so this is cumulative rainfall. This is cumulative in mm. This is cumulative. So in this hour, or in this time, this much of rainfall takes place. So if you see here, so you can say that this is if you consider it first storm, second storm, third storm, not in days. So in all the third storm or in a particular day, this much of rainfall taken place. Okay. This is like master, and you can also represent it in a hydrograph type. There is a term hydrograph. This is the graph between intensity and duration is time. So this create like bar chart like this. It means intensity means centimeter per hour. Let's take it centimeter per hour. Centimeter per hour means in this hour, like in 6 hour, like this is first storm, 6 hour first storm, second storm is 3 hour. Okay, so in this 6 hour, how much rainfall takes place in which intensity? If we have mass curve of 6 hour, like in 6 hour, the rainfall takes place approx 30 centimeter. So 30 centimeter by 6 is 5. Means here 5. So the variation between rainfall intensity and time is called hydrograph. So we also represent this rainfall in the terms of what? The terms of hydrograph as well. So these are the methods by which you have to denote the by which you can denote the like this rainfall. Okay, here you can see here you can see rainfall data represents precipitation received over a period. It is essential for hydrology, agriculture, flood forecasting, and climate studies. Rainfall data is usually expressed in millimeter in annum. We have to express it. And methods of representing rainfall data, you can represent this tabular presentation using rainfall report, like in tables. Okay, days, you can represent it. Graphical representation using bar graph or hydrographs, as I explained you, in the terms of hydrograph. In the terms of hydrograph, you can represent it, and in the terms of hydrograph, you can present it, and isohydral map showing equal rainfall distribution. In the terms of isohydral as well, you can represent this. Like suppose this is your area, and this type of lines called isohydral lines. Similarly, like contour lines, as you know that contour lines in surveying. What is the contour lines? The line which is joined same elevation. Similarly, the line which is joined same rainfall. Like this is your area, this is your area. So in that area, if at this point, this location have same rainfall received during a precipitation, then you have to make a line from there. Then you can say that what you can say that then you can say that this area have this line have the same rainfall. Okay, maps masker for cumulative rainfall analysis. As I explained you, masker. This one is masker. Here, cumulative rainfall and time. So this is master. Okay, and next you can say like what is hydrograph, as I explained you. What are the hydrographs? So hydrograph is a bar chart showing rainfall intensity versus time. It helps in runoff estimation and storm analysis. Okay, widely used in hydrological modeling. So here, like if you are a BTech student and you didn't have much knowledge about hydrological modeling, so I'm going to explain you a little bit what are the hydrological modeling, as written here, hydrological modeling. So in hydrological modeling, we are going to model hydrology. What is hydrology? Hydrology is nothing. Hydrology is just water cycle. What is hydrology? Hydrology is water cycle, about water coming, going, circulation, everything. Okay. So how we have to model it? So in hydrological modeling, there are some models. Like the model use what process? Like they have in hydrological modeling in water cycle, there are expression of water balance. You know that. Okay. So this water balance equation solved in these models, like there are so computer model. In that model they code the things. They code the things. They prepare a code, proper code, in which they enter this equation, how this equation will work, like what factors affect the hydrology, and everything they have to incorporate in the code. And they create a GUI, graphical user interface, okay, where a normal or illiterate or any person can learn this, where they have to give input data, like how you can do this hydrological modeling. The hydrological modeling, you need rainfall. Okay, what you need? You need rainfall, how much rainfall takes place at a particular point, and how it goes to the river. Like runoff is very important, where we have data, like how we can validate our model. So suppose rainfall takes place, and we have arrangement to measure this. Okay, we can measure the rainfall. Okay, so we have data of rainfall, and this done by IMD, and we have data of runoff of a river. Okay, at bridges, at many locations there are marking in the abutment and piers. So on that basis they have, and cross section we know that the bridge location they, then we can get the discharge as well. If at upstream, like this is based in upstream, the rainfall takes place, then we can measure the discharge here at a particular point. So CWC, Central Water Commission, also do, or state government agencies also do this measurement of runoff for the rivers of India. Okay, so we have this Q, we have this rainfall, we have P, we have Q. But we know that model model cannot give you, if you give it P, and it cannot give you direct R, because when P takes place on the ground, because when P takes place on the ground, then what happen? It takes place on the ground. So it first of all, there some evapotranspiration will takes place. Some evaporation and transpiration will take place. When it comes on ground, infiltration is start. So in this model, we have to give equations for the infiltration, which equation it have to solve. Similarly, which type of soil is over there, till to reach that outlet where we are calculating this discharge. Till those point, for the whole area we need to know what is the soil over there, and if we know the soil, on that basis infiltration will be calculated. And what is the land use and land cover, LULC data, land use and land cover. Why it is important? Because it give you ki how the water can travel to the surface. Like if surface is impervious, like there are concreting takes place, then if rainfall takes place on that concrete, then it automatically take runoff. It can't go to the underground aquifer. Okay, so this thing also makes sense. Like if there are agriculture area, there are forest area, so if rainfall takes place over there, then the runoff coefficient or runoff pattern will be different for different versus rainfall runoff at a impervious layer and in barren layer in built up area. Okay, so for each class of LLC, the runoff pattern will be different, runoff coefficient will be different, curve number will be different. So on these basis, many things we have to give to the model. Then model will mimic the real thing, real or surface, and then it give you the runoff. Then we have to calibrate and validate this runoff. Okay, then we can use the model. So using system, using software, using laptop, you can model, you can understand like where how much rainfall how much runoff will come, and this thing you can do using the models. And now, what is Moscow? The mass curve, as I explained you, represent the cumulative rainfall, and slope indicates slope of the curve indicate the rainfall intensity, by which we can create the hydrograph as well, useful for reservoir and drainage design. And similarly, isohydral, as I explained you, the line joint places are equal elevation, equal rainfall. Importance of rainfall data presentation help in flood forecasting and drought monitoring, supports irrigation and water resource planning, useful for climate and weather analysis, essential for hydrological engineering projects. So these are the applications of like measurement of rainfall data. Different methods are used to present rainfall data effectively. Proper presentation improves hydrological analysis and decision making. So these are the conclusion from this representation of rainfall data. So thank you for today video. We will see in let's see in the next video. Thank you.